Plenty of problems so far in these videos, looking at these first two types of substitutions. So let's take a look at a x is equal to a secant theta substitution problem, where we're substituting in the key thing to look for, square root of x squared minus a squared. So here a is a constant. This is different than, say, the a squared minus x squared, that square root. Here the constant comes first, here the constant comes second. So the problem to take a look at is we want to evaluate the integral of 1 over x squared times the square root of 4x squared minus 36. So the first thing to realize here is that this doesn't quite look like what we want. We want square root of x squared minus a squared. Right now we have square root of 4x squared minus 36. But the thing that we should do is we should do a little bit of algebra here to say, hey, we can factor out a 4, and that will make it look more like what we want. And moving that 4 outside the square root will just give us a factor of 2. So really, the denominator has 2 times the square root of x squared minus 9 in it. And now that x squared minus 9, that says that our substitution is going to just be x is equal to 3. A will be 3 here because 3 squared is 9. X is equal to 3 times secant theta. And these two things, dx and the square root of x squared minus a squared, we can fill in from the chart. Okay, so what information do we have? X is equal to 3 times secant theta. Dx is equal to 3 secant theta times tangent theta, d theta, and the square root of x squared minus 9 is equal to 3 times tangent theta. So those are all the substitutions we need to do. And when we do all of the substitutions, what do we end up with? So dx becomes 3 secant theta times tangent theta d theta. Don't forget that 2 comes downstairs. That x squared is 3 secant theta, all of that squared. And the square root of x squared minus 9, we see here is 3 times tangent theta. So this is where we're at. What cancellations? We should be looking for cancellations right now. So 3 and 3 cancel. Tangent theta and tangent theta cancel. We'll have, let's see, 1 factor is secant theta upstairs, 2 downstairs. So that's a secant theta factor downstairs. We have a 2 downstairs. And we also have 2 copies of 3, so that's an 18 downstairs. And so here is our integral that we're left with. Okay, so we see a 1 over secant theta. But 1 over secant theta, let's just cosine theta. So it's far easier for us to just say integral of cosine theta. And of course, the integral of cosine theta is going to be sine theta. Okay, so this is the integral that this is what we have. We have in terms of theta. Now we have to go back in terms of x. So we take a look at our triangle here. And so we want sine theta. So sine theta would be this over this. So square root of x squared minus 9 divided by x. So that is going to be our final answer. 1 over 18 sine theta, we said, was square root of x squared minus 9 divided by x, and all of that plus c. Okay, so that is, we've now seen examples of all 3 different types of substitutions from this chart. So your job is to recognize what's going on, and then use the information that's in the chart to evaluate the integrals. To finish off this video, I think here's a good little practice problem to deal with. So we could complete this. This one should look like this sort of substitution we just did.